Welcome back, everyone. We will now have 5 different companies, which are a mix of startups and established companies from both Singapore and Norway, to share with us different solutions or case studies that are related to digital and communication technologies. And they are also bringing new innovations to the maritime industry. During the presentations, again, if you have any questions, please drop them into the Q&A function. I would like to start with Evjen. Evjen is a Singapore-based startup company, and their vision is a world where maritime logistics is more efficient and sustainable. Evjen develops and operates proprietary aerial delivery drones, which can ultimately deliver 100-kilogram loads over 100 kilometers to ships and offshore platforms. Here to present is Mr. Nicholas Ang, co-founder and CEO of Evjen. Nicholas, please.
Hi, everyone. Let me just bring up my slide for a while. Okay, cool. So I think you guys should be able to see my slides now. So I'm Nicholas, the co-founder and CEO of Evjen. Like Daniel shared, we are based in Singapore with a vision very much to make the world's maritime deliveries more efficient and sustainable. We are the first company to have commenced commercial drone deliveries here. And in November last year, we became the first company in the world to complete a commercial night drone delivery. So at that point in time, we helped deliver a critical spare part for Wilhelmsen to Björn Hovstein. That's a vessel owned by Björn that was anchored about 5 kilometers from shore, and that delivery was just completed in under 7 minutes. The payload itself was another significant milestone, being the world's first 3D printed CE certified lifting tool for water at that point in time. The problem which we're solving with drone deliveries is that every year, launch boats, supply vessels, and helicopters make more than 2.5 million trips to deliver supplies to ships anchored within ports and also to offshore oil rigs every single year. And this number is actually going to continue to grow with the growth of more offshore assets, such as in offshore wind turbines. In addition, ports are also growing to become more congested as global seaborne trade continues to grow. And this is just a snapshot of the situation in Ningbo. And if we look at marine traffic, most of the world's busiest ports actually look pretty much like this. And we certainly therefore need a more efficient way to move people and cargo within ports, not just within the shore side, but also within the anchorages as well. And what we found out also is that the traditional means of sending items to ships and offshore platforms are pretty pollutive, adding more than 100 million tons of CO2 every single year. So if we take a closer look, an average launch actually produces more than 6 kilos of CO2 every kilometer it travels. And a helicopter, which usually flies a lot further, produces 3.5 kilograms of CO2 every kilometer they fly. They are also pretty expensive and not the most time efficient. So if we were to just take an example, a delivery by boat to a ship that's anchored about 20 kilometers away from shore, it would easily take about 2 hours, cost more than $2,000, and produce more than 100 kilos of CO2, just that one single delivery. But with a drone, the same delivery can be reduced to just 2 minutes, cost only about $500, and emit almost zero CO2. But the challenge is that drones, while they have the potential to change this, but they are not yet good enough, considering that marine and offshore applications require drones that can lift heavier loads over longer distances. This is why we are developing our proprietary drone, which can fly 100 kilometers with 100 kilogram loads. It would be an eVTOL that takes off vertically and flies like a plane. It would be aviation grade, so unlike consumer drones, it will have all the safety systems required. As a fully electric drone with zero dead weight, it will be more efficient and sustainable than any other drone, certainly in this payload range category. So this is quite a unique aircraft. It will take off vertically like a helicopter. The whole aircraft will rotate to fly forward with its fixed wings. That's how we can fly further and faster with heavier loads. And then it will land back vertically with high accuracies using computer, even on rocking vessels. Most importantly, our customers can benefit from cheaper, faster, and greener logistics. So you may be wondering, what can we carry, with 100 kilos? So on the right-hand side of this screen, these are some of the items that our potential customers have told us that are critical to their offshore operations, like drill bits, gas tanks, sensors, even live rods to be sent with our drone. And under 5 kilograms, we have found out that this is also a very interesting market because a high volume of these items, including bunker samples, spare parts, and documents are being sent to these vessels on a daily basis. So it's going to take us some time before we get to the big drone. So Hyperlaunch Heavy on the right of this screen will only be commercialized after 2023. It is a drone that would be about the size of a car that can deliver payloads of up to 100 kilos over 100 kilometers. And it would take about 18 to 24 months to get it certified for the requisite airworthiness certifications required. So far, we've been just using an off-the-shelf drone for our drone deliveries, shown on the left here, which really can do very, very little. But in between, we've actually been building model drone platforms as part of our development roadmap. In fact, we will be commercializing 2 of these platforms, namely Hypercopter, which can be carrying 5 kilos over 30 kilometers, and Hyperlaunch, which is a scaled down version of the final product, and it would itself be able to carry 5 kilos over 50 kilometers. And we are looking to commercialize these 2 drones within the next 3 to 4 months. In fact, we will most likely conduct our first Hypercopter deliveries to ships within the next 3 to 4 weeks. Hypercopter is a drone truly designed for the maritime environment. It would be free from magnetic interference, which is a huge problem when operating 2 vessels. It would also have state-of-the-art avionics that we are putting onto our larger Hyperlaunch drones. And Hypercopter would also, if we were to end up in water, I mean, we never want this drone to end up in the waters, but our customers have asked for this so that in a worst case scenario, they would still be able to track and retrieve the spare part or document, which may be the only we have anywhere else. Coming on to Hyperlaunch, we've actually built 3 Hyperlaunch aircrafts and have flown this more than 200 times autonomously. And we intend to commercialize this in 3 to 4 months, like I mentioned. So here's a quick video to show you how we have transformed an idea to something flying literally. So we are very excited about Hypercopter and Hyperlaunch flying to ships within the next couple of months. Transforming maritime logistics to be more efficient and sustainable is certainly a core focus for us, but digitalizing our operations is certainly on the top of our minds as well. There are 3 parts that we hope to achieve ultimately, and we are open to partnerships in these areas. Firstly, in the front end, which users use to book or order drone delivery and track their parcel or cargo status. Our hope is for it to be as user-friendly as an Uber or Grab in future. Secondly, it is the AI for demand supply aggregation, to ensure that our drone assets are optimized for the most efficient and timely deliveries for our clients. And thirdly, which is what we are already working on, is in digitalizing and automating the whole drone delivery process. Our drones can already fully autonomously over land, and it is just a matter of time before our drones can land autonomously on vessels as well. But before a drone actually lands on a vessel, it needs to first find that vessel. And to this end, we have integrated AIS data onto our ground control software, and our drones can automatically plot their own flight paths to minimize any flying over other uninvolved vessels already. In computer vision, we have also trained and demonstrated that our drones can find a helicopter marker by itself and land on it even when the marker is moved 0.5 meter per second to simulate the environment of landing on vessels. And with machine learning, we are working towards a scenario where our drones can ultimately land autonomously on any vessel without the need for any form of markers. So this is a big task. So we are open to partnerships in computer vision and machine learning as well. Lastly, one of our key challenges that we are also addressing is long distance communications. In the offshore environments, we do not have 3G, 4G, or 5G networks. So satellite communications would be the default option, but it is costly. So we are open to innovative solutions and partnerships which can address this need. At the initial stages, our drones would only require about 3 to 4 Mbps with less than 200 milliseconds of latency for telemetry, control, and live video feed for the drone pilots. And the drone is actually designed to make decisions by itself with its own computer. So it will transition to only requiring about 50 kb per second at steady state. So this is my last slide. I think in summary, we are keen to explore technology collaborations in digitalization, computer vision, machine learning, as well as offshore communications. And we're also very keen to explore opportunities for more pilot projects with Norwegian companies in Singapore and Norway. Thank you.
Thank you, Nicholas, for the excellent presentation. Next, we will have AOS Offshore. AOS Offshore is a high-tech asset integrity management company focused on delivering oil and gas, renewables, and Industry 4.0 goods and services to clients. It is founded by a Norwegian with operations based here in Singapore. The presenter is Mr. Peter Nilsen himself, the founder and managing director of AOS Offshore. Peter, please.
Thank you very much. Let me see if I can start this. Here we go. And hopefully everyone can now see the presentation. So what I'll do is a little bit elaborating a little bit on what Nicholas has just shared with us. I will be talking a little bit about the subsea and aerial drone capabilities. So I will do a little bit mix of what we have done and current projects that we are working on and developing. First of all, we will show a little bit about how we can do air and sea simultaneously operations, meaning that we can actually do subsea and aerial drones working together, and also have a real-time software platform that can communicate and make the operators know exactly what's going on and all the rest. The subsea and heavy lift aerial drones, I'll be showing a little bit on the logistics side. Me, myself, come from the oil and gas industry. We work a lot with oil rigs all over the region, and most of the stuff that we're dealing in is normally quite a lot more heavy than 100 kilos. And as everyone knows in this business, it's always in urgent need. And the last thing I will do is to talk a little bit about the spot-on software that we're using for this. So this is a typical scenario just to show you the capability of what we have. We can do in any case of catastrophe or an inspection scenario, we can actually multitask numerous things, and we can tie all this in together with all types of software. It is all at the end of what the client is asking for and what is the general focus on the problem and what we have to look into. The same thing will happen also for the aerial surveillance capability. And there is the drones that we will show you a little bit later is, of course, there is basically today no limit on what type of sensors can be put in to these drones. One of the things that we have been doing is subsea drones for inspections. This is a project that we've been doing together with a client here in Singapore. We were tasked to come up with a solution to come up with 100% diverless inspection. And the reason being is that they had a fatal accident some years back. From the first meeting until we delivered a full-scale pilot test, it took us 6 months. And we have now done, only for this client, 1,800 piles that we have inspected according to the API standards for offshore terminals. We have met all the criteria. What you see down on the left-hand side is probably the smallest subsea pulsed eddy current system in the world that allows you to do reading of corrosion thickness, but you don't have to clean the asset before you do that. And the last part that you can see on the side here is a inspection either under hull or we are doing inside tanks. Next thing I would like to draw your attention to is the unlimited movement and the software development that has been in this sphere. This shows you some of the pool testing that has been done with when you're using 6 degrees of freedom systems. So the software will enable us to basically enter and maneuver these subsea drones in any possible way. Now, there are 2 types of drones you can use. Is either they are surface tethered, meaning that you get power from the surface, or you can do them battery operated. Still, you will need to have a reliable system with a tether and also for transmission of a lot of information that we are requiring, that is required from the client. So it's high quality video, it is pulsed eddy current, it could be UT measurements. We also do laser scaling to see and monitor problems for our clients. These are fairly I say advanced operations, but we're using a common and off-the-shelf technology combined to with our various drones in order to see how we can solve it and do it in a very timely and safe manner. I think safety is probably the key here. Another thing that we're working on is with a partnership with a company called ACC Innovations out of Sweden. They are testing now the latest drones that has been ongoing for quite some time, almost a couple of years. The biggest and heaviest lifts currently being done is up to 400 kilos. This will allow us to deliver all kinds of logistics off to various types of locations, that being on the ship spare side or logistics solution for the drilling rigs. What you see here is actually a trial test for one of the world's largest windmill manufacturers. We are testing and simulating a robot tool that is going to be lifted up for doing cleaning of the windmill blades, as it is a huge part of the service being done to these during operation. So, and it's quite an interesting challenge that we've been through here, and also all the different type of flying that has been done. A little bit on, I know I'm aware of we're under 10 minutes, so I'm just trying to push through here. Another thing that we're currently working on is firefighting drones. This particular drones here is the similar model, but can be now lifting up to about 1,000–1,200 kilos. These drones will be fitted with the different types of systems to basically autonomous or manual go and get water to any nearby location and then drop the water over the fire that might be being a building, being a vessel, being the various problems that you will be looking into. The system that you see here has been doing a lot of extensive testing. There are different models that are being done, but we're trying to use the similar known industry grades of equipment. So it's as we speak now, there has been, well, hundreds of flights been done, and it is a part of also the certification of these drones. We are doing a two-way certification. One is for the international EASA certification side, and the other one will be one that will be moving into operating in the wind farms. As was mentioned earlier today, you are actually creating a little bit the road as you go. So some of the things that we are dealing with, there is no, or sometimes there is not even the right regulations for us to discuss, and we have to then discuss with our clients and possible solutions and see what we need to certify them against. And the last part is just to show you on the spot on software. We are using them both for flying and for subsea side. We have just put in a couple of things in here in terms of what we have done in the region. This one is down on the left here is a mooring dolphin for a client. So that is a combination of a photogrammetry and scaling, making a 3D model. And the other thing that you will see on the right-hand side is a 3D sonar model that has been done of a damaged mooring dolphin in Singapore. This particular last mooring dolphin that we were involved in had such poor visibility in the water that we had to use a combination of video footage and a 3D multi-beam sonar to create the actual model. And there is no limits for us to collect the data and overlay this onto the map and the drawings or charts. It's merely about what the client would like to have. And we try to use a lot of the technology that has been used, both subsea and so on, in the oil and gas business. So I think that is that's all from me for now. Thank you.
Thank you, Peter, for that exciting presentation and the possibilities on the various subsea and aerial drones. We will now have Maritime Robotics. Maritime Robotics from Norway is one of the internationally pioneering companies within unmanned surface vessels, USVs, and has delivered more than 60 unmanned boats to international customers within maritime data acquisition. Based on their core technology within maritime control systems, Maritime Robotics is now scaling their technologies into new business areas. Here to present is Mr. Vegard Hovstein, CEO of Maritime Robotics. Vegard, please.
Thank you very much. Good afternoon. I see that I have them. Let's see here if I looks a little bit strange on the video setting here, but okay, I'm coming out of the blue. Let's see if we can do it. There we go. I think it's better. Yes. Can you bring up my presentation, or should I do it myself? There we go. Thank you very much. So I'm gonna thank you very much for being invited. It's a pleasure to be in this seminar. I'm Vegard Hovstein. I founded Maritime Robotics in 2005. I have a background from control engineering in Trondheim, Norway, and has been working with unmanned systems for the last more than 20 years, actually. Yes, so my presentation is to show you a little bit about what we are doing in terms of unmanned surface vehicles, unmanned boats, if you wish, as mainly cost-effective solutions for maritime data acquisition, which is our main market of today. But I'm also going to show you a couple of potential business developments that we're working in within transportation. So next slide, please. So we were established, as I said, in 2005. We have 2 main locations set up in Trondheim, which is our main headquarter, and we also have a setup in and around Oslo. We are now working mainly into the geospatial mapping market, mapping if you wish, surveying, and environmental monitoring, defense security, and we also, as I said, working within transportation. We have about 5 million euro in turnover last year, and we are seeing growth of approximately 20 to 30%, have had and will have for the next year also. We are in these days passing 40 employees. We are 35 plus at the moment I wrote this slide. Next slide, please. Yeah, historically distributed over aerial products, but I'm going to talk now mostly on the surface segments we have. So next slide. So we started now our first prototypes sailing in 2007 on the Trondheim fjord, and this was well before you may have heard about the Trondheim being and the fjord outside here being the first official test area for autonomous ships. That's correct, but it has been a lot of robotic testing here well before that. So this is from 2007. It was a boat sailed around very fast actually, without any real purpose except sailing around. So the real challenge for us has been to find what should we use the technology for and how to commercialize it. So next slide. So our Mariner platform, which you saw the first prototype over here, is later now developed into a very capable product in which we have a product line. We produce approximately 1 Mariner per quarter as of now, and mainly selling into data acquisition needs. It will also be a very big platform, we think, for initial users within transportation. Okay, so next slide, please. Yeah, and the Mariner is controlled then by from a vehicle control station, a shore-based or mothership ship-based position for the user is. So this is our Otter product, our newest product actually in the USV segment, but there has been a really a commercial hit. I think we are one of the most selling USV providers now in the world of this, and also actually to Asia, Singapore, Japan, Indonesia, relevant for your region. This is the typical environment on where the Otter operates best. It's a sheltered water robot of about 2 meters with a lot of payload options. So it's really the payload that matters here, or the data acquisition sensors that matters. So main purpose of this one is then seabed mapping or bathymetry if you wish. So next slide. We can have make, for example, this kind of topographic seabed map. This is a dam, hydro dam, very fast, and we have had now very large. We have about 50, 60 of these now distributed around the world, and very satisfied customer, mainly because we are integrating the sensors so well into our software. So the user experience is efficient. Among profiled users, we have a lot of survey, geospatial data acquisition companies, but we also have such as Royal Navy and US Navy on our reference list as of now. So this is a very strong market for us right now. Next slide, please. For more harbor-oriented applicants, you can also see that this type of maps is something we can create with such a small unmanned surface vehicle. So this is where the underwater sonar makes the colored segments of this picture you see here. And we also attach a laser scanner, LiDAR if you wish, on top of the boat, and you can also then scan and make topographic XYZ maps of the what's above the sea level. Next slide. So this is again the Mariner, which we briefly spoke about. I think we don't have time for this video now. It's from Spitsbergen, also another example of data acquisition. We can go to the next slide. Next, yeah. So for data acquisition segments, we have delivered more than 60 USVs to customers worldwide. We have 2 different product platforms, one for sheltered waters and coastal open waters. What I would say specifically for the smaller version is that we are seeing now increased attention, as I said, from navies, security, relevant operators that are especially using this for harbor clearance and harbor security. So they want to check, for example, the harbor or the what can be on the seabed before maybe an important ship comes to shore. Yeah. So next slide. Yeah, good references. Royal Navy, as I said. Yeah. Next slide. And you can press play. There you go. Our core technology as technology company is really the onboard autonomy systems. So we have become good also at building the boats itself or the robots, because this is becoming a data acquisition robots. But the main core is control engineering, navigation systems, software engineering. As we move now on when this, which I would to some extent see has been a little bit hype of autonomous systems, it's important for us to focus on our core technology and actually provide and propose that to potentially all the boat builders and all the shipbuilders in the world, because we believe within a few of the best companies within maritime autonomy systems. So this will be a strategy change for us, where we will be next slide. We can propose then our next slide, please. Our a stamp or a sticker, if you wish, on any boat where it says autonomous by Maritime Robotics. I compare it to computers which have Intel inside. So this will be an important focus for us now strategically. Next slide, please. So being in Singapore, I also had the pleasure of being there for before pandemic, and one day I was also looking at a little bit of the armada of fleets, and I thought, how many of these fleets are into data acquisition, and how many are into transportation? And the answer or the percentage is pretty obvious in favor of transportation. So I think it's important for us to scale our technology, our core technology, now into the segment of transportation, keeping, of course, the important market into data acquisition well fed. Next slide. So in that respect, data acquisition, we're going to continue with our turnkey integrated data acquisition robots, but we're going to move also into transportation in a more autonomy on board way. Okay, next slide. So we were on a little bit on the headlines a few years back when we launched a conceptual study with Rakuten in Japan about a small last mile, you can call it, or not necessarily last mile, but short passage sea freighter designed around two standard containers. We almost got her, but then Rakuten decided to build out a 5G network in Japan and canceled it for priority reason. But the momentum was clearly interesting, and we have moved on a little bit since then. Next slide, please. So we have also, of course, seen that the current Mariner we have has about 1 metric or 1 cubic meter of volume, and also about 1 ton lifting capacity. We think it's an initial application tester would be very interesting for the market to utilize this proven platform into applications within transportation. Okay, next slide. We are also now actually for a customer with delivery in Q1 22, delivering or designing and building a larger 9-meter USV, which will also be even more aimed at possible usage within transportation, as you can see indicated here. Next slide. We are involved in, I would call it business development against autonomous passenger transportation. This is a vision, ship design made by Hovstein. Our role will again be autonomy on board of these kind of vessels. Next slide. To help us kind of carry these business development activities, we are involved in a project in a city in Norway called Kristiansund, which has a strait where they have an existing ferry today, small ferry, and they will now build, next slide, a new electric passenger ferry, which will have certain elements of, you can say it's going to be more autonomous. It will be automatic, but it will also be certain autonomous function and autonomy ready. So in this way, we also see that we can partner up with different boat designers, different boat builders to prove our core technology inside, maritime robotics inside. Okay, I think maybe that was my last slide. Next slide. Yeah, so thank you very much for your time, and it was a pleasure. I hope to see you in Singapore when the world is getting more back to normal, hopefully maybe next spring. So in the Maritime days there. So until then, see you next time, and have a very nice day. Thank you.
Thank you, Vegard. We will now have Super Radio. Super Radio is from Norway. They are a maritime 5G pioneer for ocean digitalization and autonomous ship. They are revolutionizing and optimizing wireless connectivity in the ocean, and their solutions can provide stable 200 megabits per second connections up to 70 kilometers from coastline. Here to present is Mr. Kun Yang, CEO of Super Radio. Kun, please.
Yeah, thank you for the introduction. Let's share my screens. Hello, is everyone can hear me?
Yes, we can.
Yes. So thank you for the introduction, and thank you for your time. So my name is Kun Yang. I'm the founder of Super Radio AS. So today I'm going to introduce our work on the marine 5G solution. So
Kun Young, can you share your slides again?
yeah, I have done that. Is that okay now?
I think it's coming up. Yep, now it's fine. Yep, please go ahead.
Okay, sorry for technical problem. A short introduction about myself. So I got my PhD from Norwegian University of Science and Technology, 10 years plus on land-based maritime communication experience. So I'm leading the world's first maritime 5G project, funded by the Norwegian Research Council called Maritime. And also we got Seal of Excellence from Horizon 2020 SME Instrument Phase 1, participated in several Norwegian and European national projects. And I was also invited as a speaker at the 5G World Summit and Asian Pacific Maritime to talk about the 5G for the maritime vertical. A short introduction about Super Radios. We were founded in 2014, based in Oslo. And in 2016, we started to lead in the world's first maritime 5G project, 14 million Norwegian kroner. And in 2017, we have developed a proposed dedicated maritime 5G massive MIMO solution, and also got grants from Innovation Norway. And in 2018, together with Evjen and Kongsberg, we have conducted the field test with autonomous ship and pre-5G LTE solution. In 2016, we built up a prototype for the user terminal, which you can put it on the ship and maritime infrastructures. And then we have built up MOU for pre-5G field tests with a small version ER Berkeley, the world's first electric-driven autonomous ship, and also get the Seal of Excellence from European Commission. In 2020, we built a more collaboration with ISP and started working on the standardization with 3GPP work. Let's take a look at the heat map, the global heat map. So it can be found that the most of the maritime activities and shipping routes are close to the coastline. And that makes our land-based maritime 5G solution very important, because that is the market, potential market is huge. It's possible to be covered by a land-based solution if we do more work on to improve the coverage and system performance. So that's why we work on that a lot. I have emphasized a lot the 5G that we're talking and we are using for the land is not what we are working on for the maritime 5G. So let's take a look at the conventional 5G. So they are originally designed for land radio propagation environments, which include a lot of scatter, reflectors, and then that can be and create a lot of reflection, the multipath for the radio wave, which is good for the current 5G solution. But if you take a look at the maritime radio propagation environment, it's obviously different from the land scenarios, because basically you have line of sight and reflection of the sea surface. So which means if you use the conventional 5G originally designed for land radio propagation environment for ocean, you will have a lot of problem. And that's why we emphasize that 5G is not a maritime 5G. And that's a big difference. A short introduction about our Maritime project. So that title is called LTE Wi-Fi 5G Massive MIMO Communication in the maritime radio propagation environment. So Super Radio is the project owner, and Professor Torbjörn Ackerman in the Norwegian University of Science and Technology is a project manager. So together we are working with NTNU, with SINTEF, Kongsberg, Tania, Tadiplan, Whitehawcom, University of Southern California, Agro University, KU Leuven, and so on. So basically, the project objective is first, the phase 1 is to optimize the current LTE and Wi-Fi system for the maritime applications. And the phase 2 is to research the dedicated 5G massive MIMO solution. So let's take a look at the conventional 5G. So the conventional 5G use massive MIMO solution, and in the environment you can see you have a lot of reflections and scattering. You create a multipath and you utilize the multipath, the multi-radio path to improve the system performance. And the coverage up to 30 kilometers. And it's not very stable for the maritime applications. But let's move to open sea environment. So we have pure line of sight and reflections. So it's very difficult to create a multipath to improve the system performance as we expected. And then, based on our many years of research on the radio propagation over sea, we have proposed the maritime 5G solution. So that's on the right-hand side of the photo. That's the structures that we have built up the massive MIMO solution to create the multipath, even under the line of sight solution scenarios. And on the right-hand and left-hand side, the figure is the POC, the proof of concept that we got in the Trondheim field measurement data. So if you take a look at the dark blue curve, that's the solution that we have. And under the same communication conditions, the light blue curve is conventional massive MIMO solution, which has been utilized for the 5G base station. So it can be found that it's very clearly that under the same communication condition, we have 10 to 20 dB extra. That means we have 10 to 100 times better on single strands, which can be used to increase the coverage and increase the stability and throughput. So that's why we are very confident that the coverage can up to 50 to 70 kilometers with high stability and up to 200 megabit per second data. The 200 megabit per second data is what we have tested in Offshore, which I'll show later. So our product will be two parts. And the first part is the dedicated massive MIMO solution, which has been used for the base station side. So that's on the left-hand side. It will provide higher reliability and longer coverage and throughput. That is the TRL 5-6. And on the right-hand side is the terminal side, which terminal product which puts ships and infrastructure, maritime infrastructure, and that has been under industrialization procedure. Here is our video about how we do the research for the MAMI project. So this is the antenna system that we built up and tested in the Norwegian University of Science and Technology lab, and we put the antenna system along the Trondheim coastline, and we use the autonomous ship provided by Kongsberg. So that's the inside the autonomous ship. So we build up different scenarios to test the radio waves, the system performance, and use very high resolution radio measurement equipment. And that's on the board what we have, and we do a lot of field tests, and that has been, the data has been used to prove our concept. It works. It is surprising for us as well, and that's world's first maritime massive MIMO channel measurement campaign with autonomous ship. And then the second video is what we have tested in the Oslo fjord with our pre-5G user terminal. So we put the terminal on a sailboat. This is the environment in the Oslo fjord. So this is where we are. So firstly, we turn on the 4G network. I say data is up and down, not very stably, and data rate is 18 megabit per second. Right after, we turn off the 4G and turn on our pre-5G solution. You see the data is the signal is very stable, and data rate is 111 megabit per second. So we have great improvements on both stability and data rate. So basically, what we want to do is we want to use our solution for the maritime 5G solution to provide connectivity for the ships, for the infrastructures like oil, gas, buoy system, agriculture, autonomous ship, and use connectivity to transfer data to the cloud and AI system, and in addition to provide real-time communication applications like video monitoring, buoy system monitoring, boat communication, environment, the same thing, and remote control, and so on. So that's pretty much what we have done and what we want to do. So thank you for your time, and that's pretty much my presentation.
Thank you, Kun. We shall now have Kongsberg Norcontrol. Kongsberg Norcontrol is a key player in maritime vessel traffic management system from Norway, and they have also a strong presence in Singapore. They are working closely with both the MPA and the Norwegian Coastal Administration. They can also share more with us on the exciting new developments using VDES. The presenter is Mr. Björn Koster, Managing Director of Kongsberg Norcontrol. Björn, please.
Thank you, Daniel. Yeah, I hope you can hear me now. Yeah, thank you, Daniel, for introduction. And let me share my screen. Or if you could bring up my presentation, maybe it could be easier. Yeah, yeah, thank you. The topic I'm going to introduce a bit more today is e-navigation maritime services using both potentially VDES and potentially 5G. I'm saying potentially because these services are still in the development phase and the trial phase. These topics were already introduced by Captain Ervik and Mr. Thomas Ting earlier today. So I'll follow up on some of the parts they already have introduced. So next slide, please. Three main topics I would like to highlight. It's the maritime services in the context of e-navigation from a VTS perspective, I would say, so vessel traffic services perspective. Really main focus is maritime safety and to a certain level efficiency as well. We do have several technology enablers, I would call them. Like today, you already have radio communication. Surprisingly, for some, maybe most of data communication or communication between ship and shore is done by voice. So we have a use case to reduce the amount of voice communication within the VHF maritime communication band. We also already today have AIS, which really provides a position of all the vessels in the area, as you all probably know very well. It also has an application service message part of it, where you can send text messages, you could provide virtual ATONs and so on. But this is highly congested at the moment, and therefore VDES is the next step of AIS. That's how we would like to see it. There you have more possibilities to explore these type of services. And also, as our previous speaker nicely introduced, the 5G for maritime, this is really something which could be a game changer as well for the VTS service providers. We do have many services which are struggling within the current voice AIS environment, and to some extent VDES will support, but some services will require more bandwidth, which I'll get back to, and really the 5G or even 4G in a maritime environment would be really good. But the problem there is, as our previous speaker also said, it's the coverage, and really good to see that there are solutions coming within this area. Finally, we have some use cases I will shortly introduce. We have our Sesame Solution 2 project and the MPA Next Generation Vessel Traffic Management System. Okay, next slide, please. So e-navigation, as already defined, so I won't dwell much on it, but it's really covering a large area of digitalization towards the maritime industry, and it's by electronic means, exchange and presentation of maritime information. So from our perspective, we provide vessel traffic services systems, giving the shore side situational awareness. So the question is really, how can we share this situational awareness with the vessels to make them take better decisions on navigation decisions and get a higher level of maritime safety. Next one. So we have we are focusing on 3 different service types as defined by IMO. The first one is a VTS information service, where we focus mainly on navigational situations and warnings, but also metrology and hydrography information, as well as electronic navigational aids. Next one. We have maritime safety information services, where sharing on navigation warning areas, for example, is a key thing, but also sharing of meteorological warnings and forecasts. Next one. And vessel shore reporting service. This is maybe one of the first maritime services within the navigation platform which will be provided. You have 2 different type of reportings. You have a pre-arrival reporting, and you have a ship reporting system, which is defined for certain special cautious area, like the Strait Rep in Singapore, where all vessels coming or all vessels which are subject to this mandatory reporting have to provide certain information when entering Singaporean waters. The same you have in Norway with the Bar Rep, and or in the English Channel, where you have the Kaldov Rep. So these are very standardized reporting systems. Okay, next one. So these 3 areas will be focus for our further development, and is already being developed, but will further enhance these in the coming years. Okay, next slide. So we have during the day already heard a bit on VHF data exchange system, that's a VDES. So you do have both terrestrial VDES stations, and Kongsberg provides both mobile station on board a vessel, which can replace existing AIS unit, as well as base station on land, which would replace the existing AIS base stations. So that's one level of the VDES, where you get coverage as you do today with VHF voice communication. But to really explore the possibilities of VDES, we also have a satellite VDES coming up, which the panel discussion also today introduced nicely, and Kongsberg has participated in this effort, and we hope to see more of these satellites coming up, so we get a more extensive coverage, of course, and hopefully that will come during the coming years. It has to come, and as one of the speakers said, it's first we need the communication infrastructure in place, and then we will provide services which can utilize this technology. So next one. Next one will be an introduction of some demonstrations and tests which have been done. I won't go into detail of all of these, but there has been one with a Coast Guard vessel using VDES satellite already in 2019-2020 in collaboration with the Norwegian Coastal Administration. We have done the systems too, where we have exchanged route information between ship and shore. We have the VASP project. We have a Sesame 2 project, which will come a video in a second, so I'll leave that. And you also have the R mode, which is maybe new to some, but it's part of the VDES infrastructure, where ships can get their position from a shore-based VDES station instead of getting it from their own navigation system, which could be very useful in critical situations where you for some reason not get your position. Okay, next one. So this is an introduction of our Sesame Solution 2 project. I don't hear any sound. I would assume you don't hear either, but it's basically presenting e-navigation voyage into Singapore port. So the idea is that the vessel early on in the voyage will be able to report via satellite VDES to Singapore VTS, and in that way get a better planned voyage as well as a more safer journey because of the journey being surveyed by VTS. Okay, we'll jump to the next one. And the next one. So introducing the MPA Living Lab, next generation vessel traffic management system. This is an innovation lab where we have worked together with MPA and our partner Singapore Technologies for the last 3 years, developing a new functionality for the next generation system. In 2019, MPA arranged an IALA workshop where we demonstrated at least 2 of these services I've been talking about. The information service, on the right-hand side, you can see a close quarter situation, which was shared between shore and ship. And on the lower right-hand side, you can see the maritime safety information, where we share the navigation warning areas between ship and shore. Also within this project, Singapore Technologies has developed their VDES ship prototype, and we plan to finish up the project in next year after pandemic allows it, I would say, to do a final test with MPA, ST, and us on using VDES ship-shore communication with the Kongsberg base station and the ST ship station. So that is really showing a collaboration between Singapore, Norway on the VDES side, and hopefully we can do more of this in the coming years, especially within the satellite as well. So next slide. The final one with some findings and summary. So there is still a need to standardize the VDES protocol to really get a major rollout, but the technology is coming along, and hopefully we can get this standardization in place soon. And the following navigation services seem to be the most suitable for VDAS. It's really about voyage reporting and basic information services such as welcome message or reporting links and what services a vessel could have. For example, if a service comes to Singapore, it can get a message on that you have these certain e-navigation services available, and then you can click on them and utilize or maybe 4G, 5G systems in the future. So main challenges with VDAS is as you know, it's a bandwidth which is limited, so it limits the service capabilities. Hopefully 4G, 5G will be a fundamental change and make new services available. And so yeah, finally, it's really about standardizing these services and the protocols used, so we can use existing equipment on board the vessels. Thank you very much for the time for this short introduction to our services, and hopefully we have some questions as well then.
Thank you, Björn. We shall now bring all the presenters back to address some of the questions from the audience. Okay, we'll start with a question for Vegard from Maritime Robotics. There was a question from Andy about whether can a MBES be mounted on your USV. I think MBES refers to multi-beam echo sounder sonar to map the water bottom.
Yes, definitely. That's what we do all day in a way. So that's our main market, and we have now we have a long list actually of successful integration delivered to customers. From the majority probably lies within the three major players on shallow water multi-beam echo sounders, which is Kongsberg, Teledyne, and Norbit. But we also have other multi-beams well integrated and delivered out to customers. So please contact us about that.
Yep, you can contact us. Contact Innovation Norway. We'll tie you up with him. Nicholas, there's a question from Natajan. What is the max load your, I believe, drones can take? And is authorization available for delivering the package in transit?
So the maximum payload for drone deliveries that we are developing is working towards something that can carry 100 kilos over 100 kilometers ultimately. But in the next 2 to 3 weeks, when our proprietary drone flies, it would be able to carry 10 kilos over 15 kilometers. With regards to the second part of the question, I didn't quite get that, but I suppose it's asking if we could send items to OPL. That is certainly something that we are looking to work towards, because OPL deliveries tend to be very time consuming, potentially 5-6 hours for a single delivery, and that's something that a drone can do in under half an hour.
Yep, thanks for the answers. And we have a question to Kun from Jeff. That the understand that 5G is more for nearshore application. How does this compare with Triton? I believe Triton is another maritime wireless solution. I'm not sure if you know this, but whether you can give a reply on this.
Well, that's a problem from my side as well. I'm pretty not sure what is Triton working for, so it's hard for me to understand this.
Yeah, sure. I think what can be done is maybe after this seminar, we could arrange for you to give your response to Jeff.
Yeah.
And finally, I have a question for Björn, which is what would a ship owner or shipping company have to invest in order to prepare for e-navigation services?
I guess that's really the main question from ship owners, and they don't want to invest in much things, but it's for VDAS, it's really to replace the existing AIS on board with a VDAS unit, which would be the same type of unit physically. It's a new investment, but it is required to improve the communication part of it.
At this stage, I think we have run out of time for this session. Thank you for all your questions. And if there's any interest to connect with any of these companies, please feel free to contact Innovation Norway after the conference. With that, thank you very much for your sharing. We shall now have a